Yeah, so I hope the screen is visible. Someone confirm? We'll start the class.
Yeah, it's visible.
Okay, all right. So we need to see triple integrals today. Okay. So all the triple integrals we have seen basics. First lecture I taught some basics. Like we did some basic evaluation of triple integrals. Today we will go in depth. Okay. Just 1 minute. Better. Carefully, we just need to keep on visualizing. Okay. It's nothing else. Visualization only should give all the other things you'll be able to do on your own. Listen carefully. There are two ways of visualizing triple integral. Listen carefully. So as you know, triple integral will be in this format: height into dz into dy into dx. What is this? This is the 3D part. And what will this be? This is height function. And height function, what will do? It will extend it to 4D. So actually, you are calculating length into length into length into length. That is, you are calculating L per 4. You are calculating something in 4D region. So we are not given a specific term for it. Volume, area, we have not called it. This is something in 4D region. Remember that. Another way to visualize is, if you take double integral, take the double integral itself. Double integral, how it will be? It will be like this. What you are doing is write height function as integral dz. Height function itself, you visualize it as another integral. Then what will happen? Then it will become, and you are finding volume. You know, on this. Same thing will be most majority of case will be doing this only. What we are doing is in double integral, what I told you as height function, that height function we are writing as another integral. So now it becomes triple integral and we are calculating volume. Okay, this concept everyone is clear. Keep responding one by one. Hope it's clear. Any doubt, please keep asking. Look at this carefully. Yeah, we always calibrate. Yeah, so volume of sphere. How to calculate volume of sphere using triple integral, that we'll see. Look at this carefully. First of all, what is the equation of sphere? X squared plus y squared plus z squared equal to a squared. Okay, visualize it. Okay, this is sphere, like this, like this, like this. Okay, x, y, z axis. Now in 2D, what in double integral, what we used to do? We always used to visualize only the 2D projection. Look at this carefully. Now I am projecting this on the 2D plane. This circle is the 2D projection. 2D projection on xy plane. Now look at this carefully. Take any point. Now first of all, take this equation first of all. From this equation, what can I say? Can I say z is equal to plus or minus under root of a squared minus x squared minus y squared? Look at this carefully. Take any point on the circle. Take any point on the circle. Let's catch this point. Now for this point, I can say height function is going from, see, catch the height function. Height function is going from z equal to minus root of a squared minus x squared minus y squared till it is going to z equal to root of a squared minus x squared minus y squared. So height function I can write as integral dz from minus root of a squared minus x squared minus y squared to plus root of a squared minus squared minus y squared. So I am applying the second format. I am visualizing the height function itself as another integral. I am proceeding. Now for the remaining part, what you will do? For limits of x and y, normal circle only. This we have already done in full double integration. How you will visualize? This, what is the equation of this circle? This circle I am drawing here. This circle I am drawing here. This circle if I am drawing here, what will happen? This circle equation is x squared plus y squared equal to a squared. So I can take vertical strip. If I am taking vertical strip, what will happen? If I take vertical strip, then My y will vary from minus root of a squared minus x squared till root of x squared, sorry, a squared minus x squared, and then x will vary from where to where? X will vary from minus a to plus a. Is clear? How does the integral? Volume equal to integral dz from minus root of a squared minus x squared minus y squared to root of a squared minus x squared minus y squared. Then you will come back to 2D. You will visualize the vertical strip. For vertical strip, I will integrate y equal to minus root of a squared minus x squared to root of a squared minus x squared dy. Then finally integrate minus a to a dx. This will be the final volume integral. Is there any sort of confusion in this? Any confusion, please ask. Tell me. Any sort of confusion in this? Let proceed. Visualization clear? For each point on the 2D circle, I am catching the height function, and I am writing the height function as one separate integral. So it becomes 3D integral. It becomes triple integral. That's it. We are actually doing double integral only. We are actually doing double integral only. Simply like on a shortcut, we are cheating. Writing the height function on integral, so it became triple integral. Okay. Tell me. I want response. Is it clear?
Yeah.
Yeah, understood.
Yeah, it's clear.
Keep responding, and only class will be interactive. But look at this carefully. Now, this visualization I have given. Now, two other visualization I want draw and show, but you should think. Okay. Suppose you are fine. Suppose you are viewing only in first octant. Suppose you are considering only first octant. Considering only first octant. Then what I can say? I can say volume will be 8 into volume in first octant. Now you think how volume in first octant I can catch. If I want to catch volume in first octant alone, then height function I should start from 0 till top. The strip also I should keep only this here, 0 to root of a squared and a squared, and the strip varying also I should do only from here to here. This visualization I will not give. I have given a rough idea. You should try on your own. 8 into what you will do? 0 to root of a squared minus x squared minus y squared dz, and y will vary from 0 to root of a squared minus x squared dy, and x will vary from 0 to a dx. Simple. This is actually better to do in the examination because you know you have already simplified one step. One step simplification is giving. One step simplification it will give you. Okay, this is one way of visualizing. Another way, if you want to visualize it as considering hemisphere. Hemisphere, what they are doing is they are taking this entire sphere and they are cutting into two. This part on they are visualizing. In this part, if you visualize like this, then you should say 2 into volume of one hemisphere. And if you observe carefully, only height function I have cut. Height on I have cut. Vertical strip will be same only. Vertical strip will be full, and x will vary from minus a to a only. Y will vary from minus root of this. Like this part will be only this part will change. This two will be exactly same. Hope you understand this. You will write the integral as 2 into this. Only z part is affected. Y part is still same only, minus root of a squared minus x squared to root of a squared minus x squared. And x is what? Minus a to a dx. But examination, like I don't think they'll tell you to do this. They just tell you to calculate volume of sphere. Best method is this only. Because you made everything 0 down. Very simple. So you can visualize as hemisphere, you can visualize in first octant, anywhere you can visualize. You should be able to get the final answer. Okay. Right like this. Need out in this sphere visualization. Can I proceed? Tell me guys.
Yeah, sure.
Yeah.
Now next we'll go to volume of ellipsoid. Nothing big for me to tell in this. Is it again coming Calibri? Give me 1 minute. Again it's coming Calibri, 1 minute. again. No, it's like this. Volume of ellipsoid. Can someone tell me the equation of ellipsoid? Someone. What is the equation of ellipsoid? Tell me. No volunteer. Ellipsoid, ellipsoid.
X square by a square plus y square by b square plus z square by c square equals to 1.
That's it over. Okay. How to find the volume of ellipsoid? I won't give any visualization, okay? Because exact same visualization as sphere. Nothing extra I could give here. Just think of what I say, okay? First you will write height function. You will write integral 0 to, for z, how you will write z? You will write, write down. C into root of a squared by a squared minus a squared by b squared dz. Clear? Then now you are bringing it to xy plane. When I bring it to xy plane, you put this as 0. This is the equation of ellipse. You're visualizing ellipse in 2D plane, and then you are drawing vertical strip. Then you will write 0 to b into root of 1 minus x squared by a squared. Then you are moving the vertical strip. That will be 0 to a dx. This will be dy, and then you are multiplying by 8 because you have considered only first operand. Is it clear? Here, I don't think I should waste time visualizing this. Exact same as sphere I am doing, but sphere la A and B, C all be equal. Here they are different. It's nothing different. I have done exactly what I did here. I am doing here. Should I really waste time visualizing, or is it clear? Tell me, is it clear now?
Yeah, it's clear.
Yeah, clear.
I will like a final answer right here. What is volume of a sphere? Radius A. You will get 4 by 3 pi a cube, right? Remember that. And what you will get for ellipsoid? Of parameter ABC. What you will get? 4 by 3 pi ABC. That's it. So please integrate. Integration on your headache only. Integration is going to be very difficult for this, I know, but you have to die only. Okay, I have no choice. You have to. It's difficult, I know. Just do it. Next we will see visualization of tetrahedron. Volume of there in MAM sheet. What they are doing is for tetrahedron, I'm giving you 4 faces. This is all there in the exam sheet. Sorry, it's all there in the sheet which ma'am has given. So what she has given is x equal to 0, y equal to 0, z equal to 0, and x plus x by a plus y by b plus z by c equal to 1 are faces of the tetrahedron. This is given. So whenever this question is a little simple only. What I am doing is I will draw xy plane alone. See xy plane alone. In xy plane, plot the equations first. What you will get? This is x equal to 0. This is y equal to 0. And this equation will be x by a plus y by b equal to 1. Correct? Z will be 0. For xy plane, z is 0, so I put z equal to 0 everywhere. I have removed this. Okay. Now this is the triangle which is bound. And for this, can I say I am having height function? What is z from this? Can I say this is height function? Think. I can say each point on this I will extend it in 3D using this height function. So some tetrahedron will get created like this. I can't draw it, it's difficult to draw. You can draw it and see. So what I'll tell integral dz, z is from 0. See, z is 0 given here. So z equal to 0 to c into 1 minus x by a minus y by b. Then I'll take vertical strip here. You can take horizontal strip also, no one is stopping you. I am just taking vertical strip for convenience. You're taking this, you're taking like this, and you're writing here what is very fundamental limits now. Here this is x constant, so y will vary from y equal to 0 to here y equal to b into 1 minus x by kata. And then I can say x is varying from 0 to x equal to a, right? So I'm taking the strip y equal to 0 to y equal to b into 1 minus x by a dy. Then I'm writing 0 to a dx. This is the final integral. It's simple. Any visualization problem on this? Clear? See for 1 minute. The problem with this answer you will get as volume will be 1 by 6 ABC. Okay. See, I am having less time. That's why I can't sit and do all the integrations. In integral, if you just put integration, volume of tetragon, everything will come. My aim is I just want you to visualize properly. Integration all you will do. Get out on this. Volume of tetragon. Can I proceed?
Yeah, it's clear.
Very good. Mari, keep responding, okay? One concept which is difficult to visualize, which I don't recommend anyone to visualize. Okay, just that this is the method. Volume. Volume. Yeah, okay, that I'll do next. First I'll do volume of cylinder. What is it? One difficulty. Volume of cylinder. How to do volume of cylinder? You'll see. What I'm doing is I'm having cylinder here. This is cylinder I'm having. Equation of cylinder is x squared plus y squared equal to a squared. I will think this is equation of circle, you know. How I'm writing equation of cylinder, you will ask. This is equation of circle in 2D plane. Now if you observe carefully, let me take this one circle. This circle equation will be x squared plus y squared equal to a squared for z equal to 0. Now take another circle, place it on top of this. This equation will be what? X squared plus y squared equal to a squared, comma z equal to 1. Like that you keep stacking cylinders, circles on top of each other. Understand? Keep putting many circles on top of each other. Keep it here. Put another circle on this, like that. So then cylinder will get generated. So I can say x squared plus y squared equal to a squared, and I can say z is, I can say minus h by 2 to plus h by 2, can I say? Because height is h. This is why equation of cylinder is written. And out in the equation of cylinder, you are catching many circles joining together in particular height region. It will form a cylinder. Any doubt on this? See.
No doubt.
Good. That's it. Now you can do it very simply. Height function I've already written. This is height function. Okay. And normal circle integration you do. Normal circle integration now only we have done many times. See, now only we did so many times. What are the limits? Y equal to root of minus root of a squared minus x squared to root of a squared minus x squared dy. Then find you integrate x. X is from minus a to a dx. That's it, over. So this is a volume integral. So you tell me what is the answer? Is that mean the final answer? Final answer is written, calculate. Listen, all integrals written practice. More any integral can come. Limits motto I'm telling how to write. You have to practice how to evaluate the integral. Tell me what is the answer? Tell me. Tell me the answer. Tell me the answer. I'm waiting for the answer.
Pi a square h.
That's it. You should get this answer. Okay, I'm writing final answer so that you can verify whether you are getting the correct answer or not. Okay. Hope this is clear. Okay. This is volume of cylinder. Now next I will tell another concept. Listen carefully. This concept is very difficult to visualize. It's actually a question I'm doing now itself. What question is this? I have been given two cylinders, x squared plus y squared equal to a squared, and I have been given y squared plus z squared equal to a squared. They're asking find volume of the region of intersection. Very difficult to visualize. Okay, I have tried to visualize it and do it with visualization, but it is very difficult. I myself have not 100% understood this, how to visualize this. So best we will learn a shortcut how to do the question faster. Okay, our aim is to do the question, not to visualize everything. So look this carefully. Method, I'll tell you how to do this carefully. First you see what is common between these two. What is common variable? Common variable is y, cut off. So for y you put limits as minus a to a. Whatever you're having common variable, put that as a limits. Common variable, what you do? X and z. For z you put limit as minus root of a square minus y square to z equal to root of a square minus y square. And for x you put limit as same thing. This is the method. Okay, don't ask me how it came. I just generated a method how to do it faster. This methodology, if you integrate, you will get the answer. So how you do integration? First you will do dz. Dz is minus root of a square minus y square, root of a square minus y square. Then you will do x, because x, y is outermost, x is inside. First we will do x to root of a square minus y square dx. Finally y you will integrate from minus a to a dy. This will give answer as 16 by 3 a cube. And out of this, just learn the method. That's it. Don't try to visualize this.
Like if this is asked in exam, can we write just like this?
You see ma'am sheet. Take ma'am sheet page number 7. 8 pages are that. Right? She has written one thing. She has written visualizing in XOY. Nothing written. You see. Ma'am sheet, she has gonna need. She has also not written anything bigger than this. This is more than enough.
Okay. I will see ma'am sheet.
See ma'am sheet page 7. You can see. Okay. Big thing. Okay. Visualization is very difficult for something. They will just draw as much as possible. You are having one cylinder like this. This will cut like this will be there. Another cylinder just like this. Something here. Some region middle, something you are not done properly. Something will be something here it will be. This boundary you can't even visualize. Something here in the middle, the region is there. Very difficult to visualize. If you just put a net and see, some complex figure will come. All that I felt it's a waste of time, because if you know the limits directly, why to waste our time visualizing? Okay. So till now what I taught is clear. See, I have done sphere, I have done different ways, I have done ellipsoid, tetrahedron, cylinder, and this I have done. Okay. Now till now what I have done is, till now I have used only Cartesian coordinates. Now we are going to use new coordinates. Just like how in 2D we did initially Cartesian and then we did polar. Here we have Cartesian, polar. So we have two forms of polar. Write that neatly. The settings of the class. What is it? Polar form in the polar form. There are two types of polar coordinates. Listen carefully. Type 1. Cylindrical coordinates is very easy. Very less visualization. Cylindrical coordinates, what you do is you will visualize like a cylinder. In cylinder, what I said? In cylinder, equation is x squared plus k only. But height on extra we are varying, so we are adding many circles. Here, how we will take it? Same thing only. You are writing x as r cos theta, y as r sin theta, and z you are not changing. Z you don't change. Don't disturb z. Only x and y alone you change. Z you keep constant. This is called cylindrical coordinates. Now can you tell me what would be Jacobian operator? Jacobian of x, y by r, theta. What is the answer? Tell me.
R.
Very good. Quick answer. Good. That's it. Okay. So you can change integral. To do the integration better. Now we will see how to use this. Okay. We will see how to use this. Better how to use this carefully. Find volume of cylinder using cylindrical coordinates. Obviously, first we'll see cylinder. Okay. Cylindrical. To find, look at this carefully. What is the actual integral? You have to do dz, dy, dx. Am I right? And z limits are from minus h by 2 to h by 2. X limits are something else. I'll just write limits. I want to write everything. Look at this carefully. What I'm doing is I'm taking the circle, right? The circle I'm visualizing, and I'll visualize as arc and strip. Remember, polar coordinate arc and strip. I'll visualize as arc. So I'm visualizing as arc. What will happen? Tell me how to visualize as arc. What do you take limits? You will take here r is 0 to r is a, and strip is varying from theta equal to 0 to theta equal to 2 pi. That's it now. And visualize like that. And height function don't change. Z you keep from minus h by 2 to h by 2 because z I told don't disturb. Don't disturb the z. X and y we are changing. So I can say theta is 0 to 2 pi. Then I can say r is 0 to a. And I can say z is minus h by 2 to h by 2 dz. Okay. And then dy dx I replace as r dr d theta. Any doubt on this? Remember polar form. There we replace dy dx as r dr dt. That's what I'm doing. Thing new I'm doing. Okay. So what to do? Now I can do integral 0 to 2 pi d theta 0 to r dr into h. We'll get answer as we'll get pi r squared h answer. Do it and see. We'll get the answer. I doubt on this. How to find volume of cylinder using cylindrical coordinates? Simple enough. Swimming? Any doubt?
No doubt.
Okay, good. Now look at this. Now we will find volume of sphere using cylindrical coordinates. Volume of sphere using actually spherical coordinates separately is there, but we have to do this also. Volume of sphere using cylindrical coordinates. How to do this? We'll see. Interesting question this is. Look at this carefully. What is the equation of sphere? X squared plus y squared plus z squared equal to a squared. Now can I say when I took the cylindrical coordinate, can I say this will become r squared? See? If this is r squared. So I'm actually having equation as r squared plus z squared equal to a squared. This is the equation of sphere I'm having. What I'm doing? I'm taking same thing I'm doing here. But here limits will not be minus h by 2 to h by 2. Limits will change. Limits will be where? What are limits for z here? Someone try now. What are limits for z here? I want someone to try. Always I'm doing. Phil, what are limits for z?
Minus
Come on.
root over a square minus r square 2 plus root over a square minus r square.
Simple, na? Same integral you will do. No? Integral minus root of a squared minus r squared, root of a squared minus r squared. What you will have? Then you will have r is from 0 to a and theta you will have 0 to 2 pi. Over. What is integral? Integral is dz. You will have r dr d theta. See? Do the integral. Do the integral, what will get? So I try this one. We'll try this. This will be dissecated separately because it's separatable. 0 to a 2 into root of a squared minus r squared r into dr. Now how to evaluate this integral? I can do substitution. You can do substitution t squared equal to a squared minus r squared. T dt is equal to minus r dr. This will become 2 pi. 2 pi into, and this I'll bring this also. This 2 pi, 4 pi, it will become 4 pi into integral a to 0 r dr is minus t dt into t. Right? So minus sign, I can interchange integrals. T squared dt. That's it. Now you got 4 pi with 3 cube. See, got the answer. The volume of sphere using cylindrical coordinates. Any doubt on this? Any doubt in any stage, please ask. Okay. With first octant, what you will do? Suppose yes, you can also do the question like this. You can take first octant na. You can write this is pi by 2 multiplied by 4 here, and you can this is 0 to 1. You can multiply by 8. All that you do, no need to show. All that use common sense and do. Suppose they say something specific, do only in first octant na. You have to make sure you are writing limits properly. Okay, you write limits only 0 to root of a square minus square. You will multiply by 2. All that multiply by 4 or whatever that you have to take care. Okay, that I am not going to show. Last question what we will do in cylindrical coordinates, and then I'll proceed to spherical coordinates. Spherical coordinates only will take time. A lot of visualization is there. Carefully. Of the portion of the between what is this by? This intersected between a squared equal to 1 paraboloid volid squared plus y squared equal to 4 minus. This question. Okay. I see it may look very dangerous, but it's very easy when you look at this carefully. You're having a cylinder. Look at this carefully. You're having a cylinder like this. Something this is cylinder is there. So what's happening if you tell me there is some curve which is intersecting like this. Okay. Some curve which is intersecting like this. Something you don't try to visualize properly. Okay. So just think down you're having z equal to 0. Up you are having what? Z equal to 4 minus x squared minus y squared. That's it. You have to integrate this down circle and z limits will be like this. Nothing different. Add out of this. Better to use spherical coordinates. Sorry, cylindrical coordinates. Right? This is r squared, no? Not you can see. You can see integral 0 to a. You can see integral 0 to 2 pi. And you can see integral 0 to 4 minus r squared. dz r dr d theta. This is the answer. This will be the final answer. Add out. We'll do this. 0 to 2 pi. This will be 2 pi only. So 0 to a r into 4 minus r squared dr. How to do this? We'll take this as t. T equal to 4 minus r squared. So dt is minus r dr. So I'll say 2 pi into 0 to a t into minus dt. What will be? So a to 0. Oh, sorry, limits I forgot to change now. What will be new limits? 4 minus r squared. 4 minus 4 minus a squared. Kata. Do it now. 2 pi into, I'll interchange the limits, 4 minus a squared to 4 t dt. I'll put 2 inside. So what will happen? T squared. So pi into 16 minus 4 minus a squared whole square is the answer. Okay, this will be the final answer. I don't know whether I did correctly or not, but concept I definitely dot correctly only. See, height function, they are giving some nonsense curve and they are scaring you. That's it. And out in this, this is all about cylindrical coordinates. Cylindrical coordinates, khatam. Okay. Should we start spherical coordinates?
Yeah, sure.
This only. Coordinates. Now, bringing ourselves to visualize this 100%. In physics, 11th physics, there's a chapter called rotational motion, which is the most G. What they'll do for moment of inertia, they will take a element, they'll combine to ring. Many rings they will add, make it hollow sphere. Many hollow sphere they will combine, make solid sphere. All that nonsense is there, right? Bring back those memories into your mind because that's what we are going to do now. Okay, bring back JE rotational motion chapter in your mind. Okay, look at this very carefully. First of all, I'll draw a diagram and show. This is X, this is Y. What will this be? You know what I'm doing? This triangle, what I've drawn here, this triangle is in XY plane. This triangle, what I've drawn and shown, is in XY plane. Now what I'm doing? Now I'm taking a line perpendicular to XY plane and putting like this. This line is parallel to Z axis. Understand? So this is perpendicular to that plane. Now I'm joining this two. And out of the visualization, this is 90 degree. Similarly, this is also 90 degree only. Okay. X, Y. This and this will form another triangle, right angle triangle. There are two right angle triangles in the diagram in two different planes. Okay. Do this carefully. And this will be Z, right? Because I'm assuming this point is X, Y, Z. So obviously this will be X, this will be Y, this will be Z. Okay. Do this very carefully. I'm defining R like this. This is R. And this is theta. This is what is this? Is theta. This is also theta because alternate interior angle property. Understand that this is theta. This is also theta by alternate interior angle property. And this will be phi. This will be phi. Now you can do all the drawings. I'll tell that. Look at this carefully. I'll explain the drawings here. This is this triangle. This is R, Z, and this is theta. Now tell me what is Z? R cos theta, correct? What is this side? This side is what? R sin theta, correct? Now you take this triangle. This triangle you take it. What is this side? R sin theta, correct? What is this? Phi. Now what is this X? This is Y. What is X? R sin theta cos phi. What is Y? R sin theta sin phi. Lay out on this. This is how you will take spherical coordinates. Lay out on this. See clearly. You can say R is distance from origin. What is phi? Angle with x-axis. And what is theta? Angle with z-axis. See, this situation clear? This is how we'll take spherical coordinates. Head out on this. Okay, proceed. Tell me what. Clear then? Tell me. No, only forget response.
Yeah, it's clear.
Don't respond, no. Huh? Chat la all talk like anything. But nearly no response. Talk, carry on.
Give us some other topic, we'll speak.
Huh?
If it's some other topic, we'll speak.
You're not studying, dude.
And the madri. Okay,
Even
okay.
I'm feeling really sleepy.
My net is really bad.
The first you.
Okay,
See now,
okay.
see how people have started talking.
Look at this. Look at this. First of all, tell me one thing. Jacobian of, do this way. What is Jacobian? You will get x equal to r cos theta, y equal to r sin theta, sin theta. No, what am I writing? Theta. So I'm not memorized. I also draw a diagram again. See, cos phi. Okay. And what is y? R sin theta, sin phi. What is z? R cos theta. Now, in summertime, what is Jacobian? Jacobian is x, y, z. You know the Jacobian is, calculate and see, you will get r squared into sin theta. Calculate and see, you have to get this. You won't get r, okay? You will get r squared sin theta. Clear? Look at this carefully. Now we will come to the question. One more thing I can do, reversing carefully. I can also define some other relations. R squared I'll get as x squared plus y squared plus z squared. This I'll get, and I'll get phi equal to tan inverse of y by x I'll get, and I'll also get theta as tan inverse of what I'll get, root of x squared plus y squared plus by z. See these triangles, you will get the answer. Okay. These are inverse relations. Just if you want, you can just note them. These are inverse relations. Not that important. We'll see. This is the introduction for the spherical coordinate system. Now we will come to the actual interesting mazza wala part. Calculating volume of sphere using spherical coordinates. Some visualization. Look at this. Volume of sphere using spherical coordinates. We did volume of sphere using cylindrical coordinates. Now we are calculating volume of sphere using spherical coordinates. Okay. We are going to calculate volume of sphere using spherical coordinates. Now look at this very carefully. Now, as I told you, go back to JEE rotational motion chapter. Get that vibes. Create that vibes in your body now. Now look at this carefully. You have small point. Now many points, join it. What you will get? You will get a ring. Join like this. You will get ring. Next, what you do? Many rings you join. Many rings you join. You join many rings like this. What you will get? You will get hollow sphere. Now, many hollow spheres you join. Join like this. What you will get finally? Tell me. Tell me, pa. Oh, let's sphere. Do you remember? Do you remember all this? From point, we'll go to ring. From ring, we'll go to hollow sphere. From hollow sphere, we'll go to solid sphere. That's what we are going to do now. Look at this carefully. I'm starting here. This is the system. Just write this. Now, I'm starting from r equal to 0 to r equal to I'm traveling. And when I'm traveling, what I'm saying is, suppose I'm here, suppose I'm somewhere here, I'll draw hollow sphere like this. I'm here, I'll draw hollow sphere like this. I'm here, I'll draw hollow sphere like this. So when I'm traveling from R to A, I am joining all the hollow spheres to form solid sphere. Any doubt in this? So to join all the hollow spheres into solid sphere, I am doing integration from R equal to 0 to R equal to A. Any doubt in this? Understand? All from here, hollow sphere, 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 solid sphere. Okay. The variable which converts hollow sphere to solid sphere is variable R. This part must be clear. Now we will take an example. Okay, I understand. But question is how hollow sphere you are drawing? How this came? For that we need to take this. So let's draw an example of a hollow sphere. I'm taking an example of hollow sphere. Now I'm saying how to construct this hollow sphere. What I am doing is I'm drawing z-axis. This is z-axis. What I'm saying is I am taking a line like this. This is making angle theta z axis. When the theta is here, I am drawing a ring like this. Then when theta comes here, I am drawing another ring like this. When theta is here, I am drawing a ring like this. Like that, I am joining many rings. When theta is here, I am drawing a ring like this. Are you all able to understand how many rings are converting into hollow sphere? Tell me yes or no. Yes or no? Think.
Yes, yes. We
Okay,
can
look,
understand.
anyone, if you have understood, you should tell me limits for theta yourself. Anyone who has understood how it happens will tell me limits for theta. Tell me limits for theta. Come on. Come on.
Minus pi by 2 by 2.
Huh? What?
Minus pi by
0
2
to 2 pi.
Okay. First ring is here. Right? Final ring is here. Now tell me. Think.
0 to pi.
0 to pi.
0 to pi is the correct answer. Think. Initially 0 was here. This ring. You're slowly increasing. Here pi by 2 came. You're bringing it down. Final angle is pi on, Final ring is here. So pi on, See. For this theta is 0. For this ring. Finally, you're coming one by one. You're coming. Finally, you're having theta equal to pi. You don't have to come this side because you're drawing this side itself. You're drawing full rings. Like you're not drawing half rings. Full ring. You don't have to again come here. Not required. This part 100% clear or not? Limits I'm explaining.
Yeah,
Clear or
clear.
not?
Yeah, no.
Okay. Now the question is, the next question what? Okay. Hollow sphere and the Ventus also understood how this came to this. How this came. This you have done many times. Think now what? You will take 5 like this, no? Tell me limits for 5. Tell me limits for 5.
0 to 2 pi.
0 to 2 pi.
This is nothing but spherical coordinates. You understand? Some concept, no? See? One limiting as an explanation. Now we'll write the final integral. What is the volume? Volume is, first what you write, r squared sin theta dr d theta d phi. Kata. What are the limits? I already written your notation again, right? Right? Okay, let's write r is 0 to a. And then what you will get? Theta is 0 to pi. Phi is 0 to 2 pi. R squared dr you write separately. All integrals are separable if you see. They are in integral separable form. So do directly, no. Don't have to wait, don't be on 2 pi. This will be 2. This will be a cube by 3. Got the answer, no? See? Tell me, how was it? Well, J y you got? From point you are going to ring. From ring you are going to hollow sphere. From hollow sphere you are going to solid sphere. This is how you will get the volume of the sphere. Any doubt? Tell me. Ma'am, just in the sheet, she just wrote the limits. I have explained to you, visualize the limits. Okay. Just please ask. Now, I'm giving challenge for others. Suppose you are only viewing in first quadrant. I want visualize it. You visualize and you want to tell me, okay? Suppose I'm viewing only in first quadrant, only in first quadrant. Tell me the limits. I will not tell. You should tell. Tell me. What is the limits for R? What is the limits for? You will write final answer. You will write as 8 into integral 8 into volume in first octant. That you write like that. Tell me, what is the limits for first octant alone? Someone think. This diagram, keep thinking. Tell me the answer. What are the limits for theta? Phi you will say. What are the limits for theta? What are the limits for R? Tell me. Come on. Let's see.
Zero to A. Fifth,
R is 0 to A, correct. Next.
next, 0 to pi by 2.
Which? Or which you are saying?
Second.
Phi या theta वा?
Phi, I
Theta,
guess.
theta.
Theta.
Theta is 0 to pi. Very good. Why? You will cover only first part. You are drawing the rings. You will only draw from here to here. Very good. Then theta.
Sine is also 0 to pi by 2.
Okay, very good. Pi also 0 to pi. This is the answer. Last challenge we'll see. Correct only what you said. These limits are correct. Very good. Suppose you are viewing as hemisphere. Viewing as a hemisphere are visualizing. Then you'll do 2 into volume of one hemisphere. Then you will visualize. One hemisphere के 10 limits. R equal to 0 to A. Theta will be 0 to 10. Theta and phi. Phi limits you tell. Hemisphere only I want. I want only this half. Tell me. Theta and phi limits you tell.
Theta 0 to pi by 2.
Very good. Phi?
Pi 2.
0 to 2 pi.
End of story. See? Once you visualize, once this visualization enters your head, very easy visualizing. Once you should do this in your life, then visualization will become very easy. Okay, simple enough. Now only one sum in this, and still one concept is there. Actually, I should have taken 2 classes, but what to do? More time. That's why it's long. I'm predicting 5:15 I'll leave. Okay, so time is 4:56. 5:15 I'll leave you. So then you can go and continue studying other chapters. Integral don't do anymore. Okay, it's one enough. Go away the other chapters. One question I'll do. Evaluate over the positive octant plus y squared plus z squared equal to a squared. So they are not going to evaluate volume. They are given a separate integral. They need to evaluate. This is identity valued. Okay. What we can do? Best we'll convert to spherical coordinates. Okay. Because you just think, see the Cartesian coordinates. What we initially used to do, minus root of a squared minus y squared. Initially minus root of something. Where you want to do all that? Spherical coordinates are very simple. Integration is very simple spherical coordinates. So better try to convert to spherical coordinates, and they return positive octant only. So we will take these limits only. We'll take only these limits. Okay. So what you will do? To write this as, do substitution. X is what? X is r sin theta cos phi. Multiply all these three. What you will get? We'll get r cube sines. We'll get r cube. Tell me what you'll get. R cube sin square theta cos theta sin phi cos phi. And because of this also you will get r square sin theta dr d phi d theta, right? Limits you will get r is 0 to a. Not only right now. We'll write after the splitting. We'll get r per phi dr 0 to a, right? And you will get all theta. You write theta. You will get from 0 to pi by 2 only. Pi by 2 only. Pi by 2 only. You will get sin cube theta cos phi d theta, and you will get 0 to pi by 2 sin phi cos phi d phi. That's it. Separator evaluate. This will become a per 6 by 6. This will become what? 1 by 4. This will become what? This will become what? Let me know. Do calculation on your own. Sin squared 5 by 2 will get 1 by 2 only will get. So what's the answer? So integral answer is a power 6 by 48. Better? Yes. Yes. Okay. So last one concept is there. Okay. Last concept, all concepts I have covered. Okay, last one concept is there, which is known as volume of solid of revolution. I'll finish in 15 minutes and then I'll end the class. Use very
Rachel,
carefully.
the common volume thing is also there, no?
Common volume I taught, no? Common volume between two cylinders I taught, no? See,
I,
I taught, no?
sorry, I don't know.
Paravala, it's okay.
See the
Taught me.
record?
It's okay, it's okay. Yeah. Look at this. Volume of solid of revolution. Let's see this concept. Okay. What I'm doing is, consider in the formula, volume will be 2 pi double integral y dx dy. We'll see what it means. First, I write the formula: 2 pi into r squared sin theta dr d theta. Okay. This two formula keep in mind. Okay. And this is our region A. A is area in XY plane. Just remember, okay. Try to understand this carefully. I'll explain first question. First question we'll write. Find volume. Same volume scale will do, but using this concept. See, volume and the sphere. We are using. See, we did sphere using cylindrical coordinate, then we did spherical coordinate. Now we are coming to same sphere with another concept. See, look what I'm doing. Taking the sphere. I am taking the sphere. This is the XY projection. I am going to take only half of the sphere. Listen carefully. Take only half of the sphere, not the full sphere. What you're doing is rotate it. Take this axis, rotate it, rotate. Can you visualize what will happen? When you rotate it, it sweeps the whole volume of sphere. Imagine it. Take it, bring it up. Full volume will cover, no? Concept and understanding. This is the meaning of volume of solid of revolution. You are taking on 2D part. The 2D you are rotating like this. It's going here, then it will go here, it will go here, it will go here. Full sphere will cover. I'm not able to draw properly. You should visualize properly. Are you understanding? If you take full sphere, then it will get repeated. If you take this and rotate now, repetition will happen. All this I can't explain completely 100%. You should understand on your own. Tell me, is anyone not able to understand? Anyone able to understand? First of all, tell me that. Are you able to understand this? How I'm rotating this? Huh?
Yes.
Which is it cut vertically? The sphere.
The sphere I'm not cutting. I'm just. No, what I'm asking?
Is it cut vertically? That XY coordinates.
Not sure. It's cut like this. No, why it's cut horizontally? You know, if you cut vertical, also it's not going to make difference. No, you take only one half. Okay, I think. Are you asking like we're having this? You want me to cut this portion, huh? Want me to cut like this?
How the
Instead of
portion is actually. How the
No, I'm
portion
not
is
cut.
actually.
This is more accurate, huh? This if I no this. Oh. Hey, no. This if you revolve, you will get. If you revolve this around, see. If you revolve this around the x-axis, now, then you will get only this portion, no? See, this will only go like this and come. But this will go fully and come, no? Think. If you're not understanding 100%, watch some video to understand. Because animation, I should show. I don't have the tools and all.
No, I guess he's saying we should rotate it along the y-axis. Then it would be correct, I guess.
Yeah. Yeah. Not sure. This visualization also. I'm also not 100% okay. You're saying you rotate like this. Okay.
I'm
Maybe
asking how you're cutting it and how you're rotating it.
Listen. You rotate however you want. Okay. I really don't know exactly. Okay. Just you rotate however you want. Okay. We will just do the somehow you should get the full sphere. Now if you integrate and see what will happen, listen carefully. You have to find volume will be 2 pi into what? Pi dx dy. This is A. And area how you will write? Area I am cutting into half now. Because I told you if you do full sphere now you will get repetition. You have to understand that. What I mean by repetition. So now try to write what is the area? Limits. Do it. Y is minus root of a squared minus x squared. 2y equal to root of a squared minus x squared. And x will be from minus a to a. Do it and see you will get the
It's
answer.
going from 0 only, no?
Yeah, sorry.
Yeah, y from 0.
Yes, you are right. Made a mistake. Yes. Okay. So you will get 2 pi y constant. No, you will not even do the question. What is the question? Wait. Do it now. What is the limits? Y. Wait. X is constant. I don't know. Y equal to 0 to a squared minus x squared. Y dx dy x is minus a to a. Do it. Are you getting 4 by 3 pi r cube? Check. Minus a to a. You are integrating with respect to y only. Y dy y squared by 2 you will get. So pi squared by 2 will get a squared minus x squared dx. And I can say this is even function. So I can bring 2 outside. 2 pi into 0 to a squared minus x squared dx. I'll get the answer here. Volume we are getting as 2 pi a cube minus a cube by 3. You are getting no? See, volume is what? 4 by 3 a cube. See, some rotation you are doing. See, you're rotating the 2D thing along 3D and you are getting the full sphere. Okay, like that we'll do for cone also. Find the volume of cone. So this is the last concept. So I'll leave at 5:15. I'm predicted correctly. Console 20. Find the volume of the cone of radius A and height h. Tell me how you will find. Look at this carefully. What I'm doing is I am considering xy plane line, considering this part. This part I'm considering. What I'm doing, I'm rotating like this. Put y-axis, I think. Y-axis only I think I'll rotate. Tell me. Y-axis, rotate like this. What will happen? You'll get a full cone like this. You'll get full cone. Are you able to visualize? You keep rotating this figure now. Rotate this figure like this. You'll get a cone like this. Radius of the cone will be here. This is radius of the cone, and this will be height of the cone. Tell me this visualization. Are you able to understand? Very important. I'm not able to understand. I have to explain. Also, it's very difficult to visualize 100%. But yeah, tell me, how you able to understand this? How cone is formed from this triangle? See, this cone.
Got it.
You're getting it. This is simple. Not this is like this only. There's no confusion. Half or 3/4. So you can do. Take the limits. Take vertical strip. Why I'm always taking vertical this time. Horizontal strip take. We take horizontal strip, what will happen? Horizontal strip is y is constant, x is varying. Yeah, but first try equation of this line. This point will be what? This point is h comma a. So equation of this line is what? Do it. Y minus y1 by x minus x1 is y2 minus y by x2 minus x1. Okay. So I can say x is varying from h by a into y, and x is a. X is a1, x is h, and then y is varying from 0 to y is varying to a. Okay, so volume is what? 2 pi integral 0 to a integral h by a by 2 h y dx dy. Right? Two integration. Oh wait. You do like this. Oh, you can do, I think. Get the final answer. We will get y into h minus h by a by dy. We get 2 pi h by a integral 0 to a y into a minus y. This you can integrate directly. A y will become 2 directly. A y will y squared by 2. So a cube by 2 minus y will get a cube by 3. So this will be 2 pi h by a cube by 6. So you will get pi h a square pi h a square 1 by 3 pi h. No, I got it. 1 by 3 pi a squared h. Right. This is the volume of the cone. Correct. You got it. Get out. See, got the volume of the cone. Last and final question and closing the session. Last and final question. Cardioid called question is there. We'll see that. They have given cardioid like this. There is a cardioid. Somewhere there, I'm not very clear exactly where they're rotating. Somewhere they're rotating. Find the volume, okay. I think I'm not sure. I think they're rotating like this. Goal from rotation they are doing. Don't ask me. I'm not very clear. Okay. Fine, last one I know. I'll do it and show. Listen carefully. What you'll do? This equation is r equal to a into 1 plus cos theta. Okay. So now we'll do this formula. 2 pi into r squared sin theta dr d theta. Now tell me. I'll take arc. If I take arc, remember polar form this is. I'm taking this is r equal to 0 to r equal to this. Then theta will be from 0 to 2 pi kata. Or I can do 2 into 0 to pi also. So I'll write like this. I'll write volume is 4 pi into theta. I'll keep 0 to pi. Okay, and r I'll keep 0 to a into 1 plus cos theta. R squared sin theta dr d theta. So r squared will become r cube by 3. Volume is 4 by 3 pi 0 to pi. R cube by 3 less it will become a cube into 1 plus cos theta whole cube sin theta d theta. So I can take this as t I can take as 1 plus cos theta. I'll take dt is I'll get minus sin theta d theta. So integral volume will be 4 by 5 by 3 a cube into integral 0 to integral theta is 0 not 2 to 0 t cube minus dt. Right on me. What I'll get? This will be pi by 3 a cube 4 by 3 a cube into integral 0 to 2 t cube dt. Correct? This 4 I'll put inside. But 4 t cube na integral is t power 4. What I'll get? Pi by 3 a cube t power 4 0 to 2. Final answer is what? 16 pi by 3 a cube. That's it. So all concepts in triple integral I have covered today.